I got a feeling that tonight's gonna be.
Hello, grade 11s from Nelson High School. This is Mr. Kendall here, and what I'm going to do today is a review of our second unit on quadratics. So please pay attention, and this is quite comprehensive, so you can review later, skip ahead, and you can always ask questions in class after you've seen this. Okay, so let's get started. We're going to review quadratics, and the first thing we're going to look at is the three ways we've written the quadratics, also known as parabolas or curves. Alright, so the first way here, we've got vertex form, and it's y equals ax minus h squared plus k. So the example would be y is 2x plus 3, okay? You know what, there's a little squared missing here, so I'm just going to add that. There we go. Plus 6. Okay, so if we look at this equation, that's an example, it would be a minimum. And that's because the a value here, which is 2, that's greater than 0, okay, which makes this a minimum. And the vertex, or minimum, occurs at the point minus 3, 6. So it occurs at the point hk, okay? And here our h value, look, there's a plus 3 here, and it needs to have a minus sign. So really the double minus sign would make a plus, which means it's minus 3 for h. And then the k value is 6. Okay, right away plus k plus 6. So the vertex is hk. Okay, the a out front gives us the direction of opening. Vertex form is great for graphing. Okay, the second form, which we're more accustomed to seeing, is standard form. Y equals ax squared plus bx plus c. And the y-intercept can be read right away from this form. The y-intercept would occur when you place 0 in for x and solve. So you put a 0 in here, all you're left with is c. So the y-intercept is 0c. Again, a gives us the direction of opening. And usually from quadratics that are in standard form, it's quite easy to factor. So here's an example. Y is minus 0.5x squared plus 3.2x plus 10. We can see that a, which is minus 0.5, that's less than 0, so we have a maximum. Okay? And right away, the c value, c here is 10. Put a 0 in for all the x's. Okay, if you put a 0 in for x, that's your y-intercept. Put a 0 in there, and you're left with y equals 10. So the y-intercept would be 10. From standard form, it's quite easy to factor. You just got to know your techniques, which we've looked at a lot. Okay, now we have factored form. So from factored form, you can easily see what the roots, otherwise known as solutions, x-intercepts or zeros would be. And in factored form, standard form is y is equal to a x minus r x minus s, where r and s are zeros. Okay, so they have the form r comma 0 and s comma 0. They're where you cut that x-axis. So where you cut the x-axis, y is equal to 0. Again, a gives us the direction of opening. The example here, y is equal to 5, x plus 3, x minus 7. Think about that. First question, ask yourself, what are the zeros? Okay, you just have to invert the sign, and your zeros are x equal minus 3 and x equals 7. As for what direction it opens, a is 5, that's greater than 0, so we have a minimum. And a minimum as 5, excuse me, a minimum as 5 is greater than 0. Okay, so just to recap, the direction of the quadratics opening is given by a. And when a is greater than 0, okay, such as here, okay, we end up where a parabola opens up and the vertex would be a minimum. And then the other case is where a is less than 0, a negative number, and the parabola will open down and the vertex is a maximum. Okay, how do you convert between the different quadratic forms? We've done it a lot. Maybe we haven't spelled it out, so I've done that here. Okay, we can change forms from these three types of quadratic forms to the others, and this is what it looks like. So if you're in standard form and you want to get the factored form, you have to factor. If you're in standard form and you want to get to vertex form, you would complete the square. If you were ever in factored form and you want to go to standard form, you'd use the distributive property or you'd use FOIL. Okay, and really I should have written FOIL out. I'll do it once here. We think of it as FOIL. Firsts, inside, outsides, last. And again, moving on, factored form can go to vertex form. You just have to use the distributive property and or FOIL, and then you would complete the square. Now moving along, we can go from vertex form over to standard form. You'd use FOIL and the distributive property, and you'd simplify. And then to go from vertex form all the way to factored form, okay, you'd use FOIL, the distributive property, you'd simplify, and then you'd have to factor. Okay, we talked about this this thing called the discriminant, and this discriminant's part of your quadratic formula. And this discriminant tells us how many solutions will exist in a quadratic equation. Okay, so the discriminant itself is b squared minus 4ac. Now there's different solutions to a quadratic. There's actually three. You could have two solutions, so x equals some number, x equals another number. And you could have one solution, x only equals one number, or no solutions. So when you look at the discriminant from your quadratic formula, b squared minus 4ac, if it's greater than 0, you'll have two solutions. If b squared minus 4ac is less than 0, you'll actually have no real solutions. Okay? We say no real solutions because I'll tell you there's these numbers that exist called imaginary numbers. And later on, beyond grade 12, you may encounter them, but for the purposes of our course, they're not considered. The other case is if b squared minus 4ac is equal to 0, that would be one solution. Okay? So the example, how many solutions does minus 4x squared plus 12x equal 9 have? You have to solve this quadratic equation. Will you have two solutions, no real solutions, or one solution? Okay, so here's what you need to do. First off, have a look at the equation. Minus 4x squared plus 12x equals 9. They're just trying to fool with you here. You want to get this so it's in the form ax squared plus bx plus c. So just rewrite that, okay? Send the 9 over, and you get minus 4x squared plus 12x minus 9. And right away, when you look at that, you should be able to pick off your values, okay? A is minus 4, B is 12, and C is minus 9. Now take your discriminant formula, b squared minus 4ac, okay, right here, and substitute a, b, and c into where you see b, a, and c, and come up with the answer. So really I take my b squared, which was 12, right, minus 4 times a is minus 4, c is minus 9, and you just have to use your BEDMAS properties and simplify this, okay, and you'll end up getting the following. Okay, that's 0. So b squared minus 4ac for this particular quadratic is 0. So since the discriminant b squared minus 4ac is equal to 0, okay, it's this case, so there would only be one solution. All right, moving on. We actually started the unit looking at these things called radicals, and they tie back to our exponent unit. What we want to do with these radicals is they provide us a method of solving quadratic equations typically, such that the answer we get is what's called exact form. Okay? The exact form. No decimal numbers. So here's an example. You'd be asked to simplify and leave in exact form the following radical numbers. So let's work this out, okay? In fact, you probably should try this on your own and pause here and then come back and check to see if you got it like I have. So let's give you a chance to do that. Okay, so square root 75 minus square root 80. Let's simplify that. What two numbers multiply to give 75, and ideally numbers that have perfect square roots? Okay, so I'm thinking of the number 25 and the number 3. 25 times 3 is 75, and then the square root of 25 is nice, it's just 5. We want to put that number first. Put that number here for a reason, and I'll show you in a sec. Now, square root of 80. Okay. Well, two numbers multiply to give 80. And also try and think of numbers that have perfect squares. So, I mean, 1 has a perfect square, 4 has a perfect square, 9 has a perfect square, 16 has a perfect square, 25 has a perfect square. Okay, I can find root 4 and root 20. Okay, that's a perfect square. The square root of 4 is 2. That's a perfect square. The square root of 25 is 5. I put them first because those are the ones that are going to simplify down. Can you go any lower than the square root of 3? No, you can't. So it's 5 root 3. Okay, you write the number, then the radical. The multiplication between the two is implied when the number precedes the radical. Okay, here you're left with 2. Okay, now look, root 20, it can go down further. What two numbers multiply to give root 20? Again, think of your perfect squares, think of some numbers, and you should come up with root 4, root 5. So root 4, root 5. Okay, again, I write the root 4 first, the root 5 second, because I'm smart. I know root 4 will break down, it's just 2. So continue. This term hasn't changed. It's minus 2 times, this is 2, and square root 5. I can't get any lower than that. It's just 1 times 5. Okay, one last line here. 5 root 3 minus 4 root 5. Okay? And that's your final answer. This is the exact form. No decimals. Final answers have a coefficient and a radical per term, okay? You can't have some number, a radical, a radical. You only want a number and a radical, a number and a radical. Okay, the second example we want to look at would be the following. 3 plus the square root of 72 over 3. Let's try that one. Okay. What do we do with this? Well, you're going to have to take a look at that square root 72 and think of some numbers that multiply to give 72. And the numbers you should think of should include numbers that have perfect squares, if it's possible. Usually is, but not necessarily. So 3 plus, and 72 is root 9, root 8. Okay, over 3. Okay, why did I write the root 9 before the root 8? Because root 9 is a perfect square. It becomes 3. So this is 3 plus 3, right? Root 8 over 3. 3 plus 3 root 8 over 3. Okay, I'm going to just do something here. I've noticed there's some 3's in each term, so I'm going to factor out 3 That's 1 plus root 8 over 3. And now I can cancel these 3's. And I've got 1 plus root 8. Am I done? Does that look right? 1 plus root 8. Can't root 8 break down further? Sure can. It's 1 plus root 4, root 2, 1 plus 2, root 2. Okay, so that's your final answer. Now here's a tip. You're going to be allowed your calculator. Why don't you check if it's right? So what do we have? 3 plus the root of 72 divided by 3. It's 3.828. Then our final answer is 1 plus 2 times root 2. Same answer. Yes, it's right. So you're happy. That's good. You've checked it. You can move on. Okay, so next we looked at solving quadratics. And here's what's happening here. So we solve quadratics, y equal ax squared plus bx plus c, for some y value, and usually y is equal to 0, and we can use the following techniques. We can factor. So here's the example. Let's solve x squared plus 5x plus 6 equals 0. Okay, well that's a simple trinomial, so we're going to use the product sum rule. Product of 6, sum of 5, the numbers are 2 and 3. So there's your numbers, x plus 2, x plus 3, and we have to solve that in parts. So the first part, x plus 2 equals 0, or the second part, x plus 3 equals 0. There's two solutions. Our discriminant check could also validate that for us. Okay, so the answers are x equals minus 2 or x equals minus 3 are the solutions. We also do this graphically. If you were to graph these equations, you could determine where the solutions are, where this is equal to 0, which is just where it crosses the x-axis, and you could see it that way. Another method is our quadratic formula. Okay, guys? So this guy here, the quadratic formula, you will need to know that by heart. Okay? Memorize that. Okay, so the quadratic formula here, we're going to use it now to solve the same quadratic from the factoring example. So solve x squared plus 5x plus 6 equals 0. So the first thing you need to think about, what are my a, b, and c values from that quadratic? Okay, so right away, same quadratic here. You should see that a from the standard form, b and c are the following. So a is 1, it's like there's a 1 here. B is 5, c is 6. Okay? So let's write out the quadratic formula. Okay, now let's start substituting our values. So here we go. We put b here is 5. Make sure you have this minus sign here. Put your 5 in. It's plus or minus. It's 5 squared minus 4 times 1 for a. C is 6. Over 2 times 1. Okay? So that's minus 5 plus or minus, what is that? 5 squared is 25. Minus 4 times 1 times 6, it's minus 24. Okay? Over 2. So that's minus 5 plus or minus the square root of 1 over 2. Minus 5 plus or minus 1 over 2 And then here we're going to break it into the two parts. Okay, so it's minus 5 plus 1 over 2, or okay, so that's minus 4 over 2, minus 6 over 2, and you should get that x is minus 2, x is minus 3. Okay, x is equal to minus 2 and minus 3. Over here earlier, we used factoring, same answers, same two solutions. So the solutions are okay. Moving on, next we want to look at optimization. That's a new term for us, and I don't know that most of you had used that in everyday language. However, it's pretty simple. It means to find the optimal value or the best value. And usually the best value, depending on the case, is either a maximum or a minimum. Okay? So when you've given a quadratic in vertex form, y is equal to ax minus h squared plus k, the vertex can either be a maximum or a minimum. Okay, so you know what your parabolas usually look like. So if you have an xy axis and you want to draw any particular curve, okay, sorry, it's a little sloppy. The vertex here is this maximum point. Okay, in this case that would be a max. You can find this vertex point by either completing the square. Okay, completing the square gets a quadratic into vertex form. So this one's already done. But if you had standard form or factored form, you could complete the square and figure out the vertex. The vertex is hk. We found that earlier. You can also partial factor. So you're going to want to know these two techniques. So let's have a look at some examples. Okay, so completing the square. Find the vertex by completing the square and state whether it is a maximum or a minimum. The example is y is equal to x squared plus 18x plus 91. Okay. Whenever we took this up in class, if you go to our course website, we did a lesson on completing the square. So Unit 2, Quadratics, and whenever we completed the square, okay, we had a full lesson on that, and it's right here. Lesson 3, completing the square and partial factoring. It was on Monday, October 1st. So this lesson is available for you by clicking here if you need to review this. Okay, completing the square. Here we go. Y equals x squared plus 18x plus 91. So here are the steps. Okay, we're first going to rewrite this as follows. Okay, we want to look at these two terms and pull out the coefficient in front of the x squared. Now the coefficient in front of x squared here is just 1. Okay, and so it's x squared plus 18x. There's really nothing we can factor out. When it's just 1, just the numbers themselves get carried down. Okay, and then plus 91. Don't forget that. Okay. Next step, have a look at this number, and on a little side calculation, you're always going to do the following to that number. You're going to divide it by 2 and square it. So the number is 18. If you take 18, you divide by 2, you're left with 9. You still need to square it. Okay, and that's 81. Okay? So 81. What do we do with 81? Well, here's what happens. Y is equal to 1 x squared plus 18x. And we're going to add and subtract 81. So we're going to add 81, subtract 81. And really that's like to the equation, we're not doing anything. We just added 0 because that'll simplify to 0. Okay, don't forget your plus 91. Okay. Now right here, these three here, we've set up a perfect square trinomial. And to get this perfect square trinomial written on the next line, you do the following. Okay? Okay. We're dealing with the perfect square trinomial part. X squared. What's the square root of that? It's x. (81). What's the square root of 81? Whoop, it's 9. Okay? Okay? What's this sign? It's a plus, so bring the plus down here, and then you put the square here. Now, this number times 2 has to equal the middle number. Let's check that. X times 9, 9x, times 2, 18x, it checks out. X plus 9, and 2 there, so it's x times 9 times 2, it's 18x. You're good to go. Now, you can't forget, you've only dealt with these three. You need to deal with this final number here. And you need to make sure you're multiplying your coefficient you brought out here into it first. This is really easy, it's just 1. So 1 times minus 81, it just comes out and it becomes minus 81. Okay? Don't forget to bring down your plus 91. Okay? Your fourth and final step. 1, okay, times x plus 9 squared. The fourth and final step is to simplify these numbers. Minus 81, adding 91 to it, you're left with 10. Okay? And really, a 1 here, you don't need that. It's implied, so the cleaner final answer would be the following. Okay? And you've got this vertex form now. Y is equal to a x minus h squared plus k. Remember, the vertex is hk. Okay? A is your direction of opening. Okay, so let's go back to the question real quick here. It says, find the vertex by completing a square and state whether it is a maximum or minimum. So let's find the vertex and state whether it's a maximum or a minimum. So the vertex here, for this particular question, okay, the usual form is x minus h. We have a plus 9. That means the h value is actually minus 9. Okay, and the k value is just 10. Minus 9, 10. Now, a here is implied. It's a 1. From earlier, it's 1. So a is equal to 1. 1 is greater than 0, which means we have a minimum. Okay? There you go. Vertex minus 9, 10. All right? Let's take a trip over to our good friend Wolfram Alpha. And I've already done this ahead of time. Y is equal to x squared plus 18x plus 91. And hit equal. And lo and behold, a nice plot. We've got a nice quadratic. It's got a minimum. What else did it tell me? Remember, I just inputted the quadratic. Scrolling down here, we've got a global minimum. The min of that occurs when y equals 10 at x equals minus 9. So again, a great tool for checking. Well, we're dealing with optimization, and what we just did is we found the vertex for a quadratic by completing the square, and the second method is partial factoring. So when we partial factor, we can also find the vertex. So here's the example here. Find the vertex by partial factoring and state whether it's a maximum or a minimum. Same equation, y is equal to x squared plus 18x plus 91. Now the lesson we did for this is also on our website, and you come down to the same one from complete the square. Lesson 3, complete the square and partial factor. Okay, I'm just going to quickly open it and let that load. So here's the lesson, and we developed all the different rules for our forms. Okay, there were 4 steps to completing the square. There are here's an example where we repeat those steps, and then we introduced partial factoring, and there were 4 steps here spelt out on the right, and I'm going to go through those now with this example here. So find the vertex by partial factoring, state whether it's a max or min, y is equal to x squared plus 18x plus 91. Okay, so first step, take a look at these 2 terms only and set them equal to 0. Okay, second step, common factor. Just common factor. So we can take x and x, that's it. So it's x that's common, and then what goes into x squared is just x plus 18, and it's equal to 0. Okay, you have to break this into its 2 parts. X could equal 0, or x plus 18 could equal 0. So we already have one of our answers. Here, x has to equal minus 18. Alright? And the third step, what we found here allows us to use the symmetry of a quadratic, or parabola, or a curve. And this symmetry means that these 2 points, their average is the x value of the vertex. So the x value of the vertex is the average. So to find an average, add the 2 numbers up and divide by 2. Okay, so you get minus 18 over 2. And x is minus 9. So far what we know about our vertex, okay, its x value is minus 9 and some y. So in the 4th step, you go and figure out what the y value is. You've got this equation, y is equal to all that. Well, now that you have the known value of the vertex for x, minus 9, substitute minus 9 in for x, and you can get the y value. So we can say the following. Y at the value minus 9 is equal to minus 9 squared, comes from here, x squared minus 9 squared, okay, plus 18 is minus 9 plus 91, that's 81. Okay, I mean, I've got to use my calculator just like you. What's 18 times minus 9 right here? 18 times 9, that's just 162, and I've got to put my negative sign. Negative 162 plus 91. Okay, work that out, and you get 10. So the vertex is actually minus 9, 10, and that's exactly what we said it was earlier when we checked wolfram alpha we put in the same equation, and right away it told us the minimum is x equals minus 9, y is 10. So same answers, that's exactly what you expect. Okay? Now, the other question, is it a max or a min? You come back to your original equation, all right, and there's a 1 here, a 1 before the x squared. Your a value is 1. Vertex is minus 9, 10. Since a equals 1, and that's 1 is greater than 0, right? What does that mean? Well, when a is greater than 1, there's a 1 here, 1x squared, it's a minimum. Look at the graph, it's a minimum. Okay, moving on, we've built up all these different techniques here in our quadratic unit. We arrive at quadratic applications. People like to call them word problems. So everything we've reviewed can be considered our toolkit for quadratics. All these techniques that we just looked at. We're going to use this toolkit for quadratics to solve real-world problems that are quadratic in nature. And it's really just like a plumber who shows up with their toolbox, a carpenter. It's the same idea. We've got all these tools to choose from to basically solve problems within our field. So we need to know how to use these, and it's word problems we're focused on and that really test us with respect to this. Okay, so here's the types of word problems we looked at in this unit. And why? Well, variables that are occurring in these word problems work out to quadratic relationships, x squared type relationships. So the first kind we looked at was numbers. We looked at revenue type problems, physics type problems, and shapes, so like area, volume. Okay, those are the big four. I think I'd said big three because I considered numbers the same as shapes, numbers and shapes. So really there's sort of four. Let's look at them. First kind, numbers. Okay, so here's numbers. Here's an example. So subtracting a number from half its square gives 13. Find the possible values in exact form. All right. A lot of people struggle with word problems because you have to take words and you have to extract information that's mathematical and then construct the proper solution using the let statement, the right equation, solving that equation, presenting your answers. Let's break down this two-sentence problem, and you'll see here below I've used some color. Okay? So here we go. Subtracting a number. What are we going to use for a number? We're going to use x. Okay, so from half its square. Well, its square, who's its? It's the number. And the number we said was x, so square x, and you get x squared. Okay? Another word here, subtracting, that should have made you think of the minus symbol. I'm just sort of building everything I'm going to show you here. So when I read that question, I actually think of the stuff in green. So subtracting, I right away think of minus. A number, I'm going to assign it a variable of x. From half, okay, I missed that earlier, but half is divided by 2. Its square, well, I think of x squared. The word gives means equals, and 13 is just your answer. Then it says find the possible values. Well, find the possible values means the solutions. And then in exact form, well, exact form means no decimals and you have to use radicals. Okay, so that's how I read that. And you should do these more often, and you can practice and get accustomed to immediately seeing the stuff in green or thinking about it, and that helps. Okay, so let's actually solve this, and we're going to do that right here. So let x here be the number. Okay? Got some number, call it x. And when you reread the question, some information you have is at one time they said we needed to square x, and then we need to half that. And back in the question, okay, subtracting a number x from half its square, okay, subtracting some number x from half its square. So we're going to subtract x from half its square. So here's half the square of x, and it tells us we have to, here's half the square of x, and we have to subtract that number from it. So we have to subtract x from it, like it says in the question. And also in the question it says gives 13. Well, that means that that is equal to 13. Okay? And let's lose the decimal for a sec here. Think of it like this. 0.5 x squared minus x, bring the 13 over, that's minus 13 equals 0. And now you have your quadratic in standard form. There's your A, B, and C. Okay? So A is equal to 0.5. Okay, that's still an exact number, which we'll fix in a sec. Give me a minute here. So B is equal to minus 1, and C is equal to minus 13. Okay, there are your values. So why do we set that up? Well, when we solve these equations, we typically use factoring or the quadratic formula. So I'm going to set this up, the quadratic formula. You would not want to factor this. It's going to be difficult due to the nature that it's got decimal numbers. So we need our quadratic formula. So here's our quadratic formula. X is equal to minus b plus or minus b squared minus 4ac over 2a. So now we need to replace a, b, and c into the quadratic formula and solve this equation we made. Okay? So let's do that. Okay, so guys, I'm going to write this out. I'd like you to try it and pause and check the answer when you're done. I'll be back in a sec with the answer. Alright, hopefully you've tried this on your own. Let's have a look. I've done it here. So we're solving for x, and we arrive down to this line here. 1 plus root 27, or x is 1 minus root 27. Well, you're not done. Keep going. You can break down root 27 like we learned with radicals. Root 27 is root 9 times root 3. Same thing over here. And your final answer is x is 1 plus 3 root 3. X is 1 minus 3 root 3. So there's two solutions. Okay. The discriminant could have told us this as well. So we end with a statement. The possible values are x equals 1 plus or minus 3 root 3. And that satisfies our formula that we develop here. Okay, so this particular question said to leave this as exact answers. And here you can see they're exact. 1 plus or minus 3 root 3. There's no decimals here. Here's how you can check your answers. Okay, so we started with this quadratic. And we have A, B, and C. I've told you before, you can Google a quadratic equation solver. We're going to carry over the values of 0.5, minus 1, and minus 13. So here's one, and you carry over 0.5 for A. You carry over minus 1, minus 13, and you hit solve. Okay, this output is the two solutions. Obviously not in exact form, but that's okay. Just remember these numbers, 6.196 minus 4.196. Now watch with your calculator yet another way you can check this. Okay? So our answers are 1 plus or minus 3 root 3. With your calculator, 1 plus 3 times root 3. Give me that number. Next, 1 minus 3 times root 3. And you get the same two answers from the quadratic solver. You get the actual answers as decimals, but they're not exact. Nonetheless, it still confirms things for you. So it's a great tool. Okay, so we were looking at quadratic application word problems. So far, we looked at a numbers example. Now there's revenue, physics, and shapes. Okay, so for revenue, where you've got revenue versus price or cost, here's what I'm recommending. We did an achievement check. You handed it in. Everybody did very well and got feedback. Review that, okay? This achievement check from your textbook, page 119, most of you got it right because it's from the same textbook on pages 114, 115. Example 5 is exactly the same. So I recommend you review that again and bring any questions you have. Okay, for revenue, these are very typical questions. The third kind's the physics problem. Okay, where you're launching a ball. For those types of problems, I recommend you check out example 3 from our lesson on Thursday, October 4th, which you can access from this tiny URL or our course website. Right? And you can also check out my YouTube channel where I've solved page 131, number 29, as it's very similar to the example from class. Okay? There's another question that's very simple, and you can access that through here or my YouTube channel. It's Mr. Kimball on YouTube. The fourth kind of question has to do with shapes, area, volume, perimeters. Okay? You are able to see the homework, page 130, 131, number 16 and 18, and I have, again, solutions up on my YouTube channel. And you can access that through this tiny URL, through our website, on YouTube, Mr. Kimball. Okay? Be sure to bring any review questions you have to class about all of this. Now your actual review, which I'll show you in class, is posted on our website, all available for download, is the following. Okay? So the review questions from your textbook are the following, from page 154. And I've got some handouts with extra stuff that you'll want to check out. You'll only do the circled questions from these. You'll only do the circled questions from them. Okay? The other kind of problem we looked at that I'd like you to review, and I'll just mention it here, the type where, well, the one we did in class, and it had to do with a tunnel. Okay, so have a look at that kind, and I think that's pretty comprehensive for this unit. Any questions you have, I'll gladly answer them. Send me a chat, discuss in class. Thanks, guys. Have a good night, and we'll see you soon.
I got a feeling that tonight's gonna